This is the battery management system trainer with Kalman filter based SOC estimation. We are using it for EV motor characteristics analysis. So apart from that, what we have a BLDC motor over here. Those are actually used in EVs. So the BLDC motor speed can be varied through this throttle. So this start button, if pressed, the motor starts, and whenever we give a throttle signal, the motor rotates based on the throttle input. Now here, this is the app where the BMS values, the battery values can be seen. As you can see that the charging is now on. The SOC, that is the state of charge, is now 98%. Charge balance is on. Now since the batteries are enough charged, so the protection is off. If somehow the battery voltage falls below 48 volt, because the motor is 48 volt, so the threshold we have set it as 46 volt. If it goes below 46 volt, we will see the protection will be off automatically and there will be no power flowing to the motor. Otherwise, there will be damage to the battery. So the current battery voltage, battery back voltage is 52.82 volts. In the indicator, it's showing physically as 52.7, so almost similar. So this what we are getting from the BMS. The maximum high voltage is 4.082 and the maximum low voltage is 3.9, as you can see from the indicators. So they are almost balanced. The voltage difference is around 118 millivolt. Since we have not activated the motor, so that is why there is no power is getting consumed. So with this setup, we also have a custom BMS. The custom BMS setup we are using for, so we can connect the custom BMS setup with this separate two batteries, and we can apply our Kalman filters or any algorithms which is required or which can be developed or designed for research. And the characteristics of the BMS as well as the motor characteristics can be observed for different throttle inputs. So this section is for training, and the Kalman filter section, that is the custom BMS section, is for research. Thus the panel not only focuses on training as well as the research purpose also. So let us first see how this panel functions. So the whole panel has been turned on. Now if we give a throttle, so we just give a throttle, there will be no output since I have not turned on the contactor of the motor. So once the motor contactor has been turned on, now if we give throttle, we can see the motor starts rotating. So the motor speed is varying, and based on that we can see the battery pack status is now decreasing because the motor is running completely on battery, and you can see the battery voltages as well, 3.8 volts and 3.9 volts, and the current you will be also able to see what currents it is flowing. So in the BMS section, if we also go, so in the BMS section also you will be able to see, so the SOC has been reduced to 97%, the state of charge has been reduced to 97%. So it is showing the estimated empty time, so it's 3 hours. The charge balance is on, the discharge MOSFET is on, that is this MOS. The total voltage is now 52.67. Again it has gone to 52.7 because I have stopped the motor. So again if I start the motor, we will be seeing the dip in the voltage. So as you can see, the current is now 3 amperes. The power is around 150 watts and the total voltage now reduced to 48.19 volt. So in the application, if you want to check the temperature of the battery pack of the different MOSFETs, so we can also visualize the temperatures of the MOSFETs in degrees and Celsius, as well as these are the individual cell voltages. So I am running the motor, so green means that is completely charged and gray means that needs to be discharged. So some of the batteries are getting more charge, some of them getting post discharge depending on their health. So those batteries which are getting discharged, so gray means they are cut off, and we can go to the parameters. Now the most important part is, if we see the parameters, this is basically showing the voltage and current variation with the load, the way the load is changing. So from this curve we can see the variation of the ampere hour with current, the temperature with current. So lot of curves we will also be able to see through those. We can also take the data to the IoT cloud platform. That is the biggest advantage of this setup.